I hope you can see my screen, yeah?
I can see your screen up.
All right. Um, so basically, prediction. For instance, you are given the list of range of data like this. So you have your month, your cost, and you want to term this A, A made, B made, and C made. And the cost here, they are all in dollars. And you have 16 months. This covered a period of 16 months. And you are told to actually predict. I'm going to type this here. You are told to you are told to provide to send in your prediction about A, B, or C model. Okay. And at the end of the day, what you are being given is a predicted monthly cost for each of the models. So we have predicted for you have 120 no, let's say you have 120 A, A model. You have 800 for B models. Of course, when you talk about cost, we're looking at dollars, right?
Yes.
Then the third one we have $1,000 for C model. So simply put, if you want to read about predictive analysis, just want to see the theoretical explanation for this. So it says here the other time we were looking at correlation and regression. If you can actually look at the differences between the two, the first was clear when we tried to have or create a correlation between column number one or column A, B, and C. We tried to find out if they were actually stable in terms of having plus one, if meaning that all of them are moving on the same range, that's positive one. And if you have a negative one, it means that they move in opposite directions, right? You remember?
Yes.
And then the last one is you have the zero, which means that they are totally unrelated.
Unrelated.
So that is correlation. For analysis, predictive analysis, that is the opposite of correlation. And you can see definitions of that under regression. It's called the regression analysis tool, and it helps to analyze how a single dependent variable is affected by the values of one or more independent variables. Remember when I gave you the example of somebody moving from one bank to the other and getting a loan of $5,000 for each of the banks.
Yeah.
And we are going to have a zero correlation because there are totally not just unrelated, but they are very much inconsequential. They mean nothing. But if the person, if we have data of the person collecting the loan, paying in a certain amount of interest, or sending in some monies in installments to the different banks, then we can have a correlation matrix to show us that there is a correlation between this person in bank A compared to whatever activities is carried out in bank B and compared to what is going on in bank C. But if you will just have the data of the loan from the particular bank, we are from one bank and another without further details about that client or customer, then we cannot have any correlation. We can't even plot the graph. And should we even attempt to do it like we tried, you'll definitely see that hashtag div /zero error, which I explained, of course, means that you cannot divide anything by zero. On Excel, it's definitely going to give you that error. So for regression analysis, we are actually looking at how is that person's amount in the bank, which we call a single dependent variable. How is it affected by the values of one or more independent variables? Like, how is the fact that this person goes to the bank to collect money, how can we, which that act is of course very dependent on the bank giving the loan, but the bank is an independent variable. So we are in regression analysis, we are simply going to analyze how the dependent variable is connected to the independent variable. For instance, what would make the guy to be given a loan of $5,000 from the bank? As someone who is totally dependent on the bank giving the loan. And what makes the bank as an independent variable in this case to actually give out that loan to the person. So that is what we want to say. Because for anybody to sue the bank tomorrow to say, why did you give out the loan of $5,000 when you know this person is not going to pay? Okay, that you would definitely need to ask yourself, it's not going to be correlation, it's going to be, you are going to use the regression tool part, or the regression analysis tool, to provide answers to that question. I don't know if this introduction is making any sense to you.
So it's making sense. I understand what you're saying now.
All right. Now they gave an example here. For example, you can analyze how an athlete's performance is affected by such factors as age, height, and weight. And again, if we want to take this example and extrapolate it to the previous example I gave, we would want to analyze how is it that this guy was able to get a loan of 5,000 naira without any obligation to pay back from the bank. Could it be he's the son of a rich politician? Could it be the owner of another bank? Or could it be that he was paid as a result of one of such values, or just like we have the atlas performance? Could it be that there's something that influenced the bank giving out this? So we can apportion shares in the performance measure to each of these three factors based on a set of performance data, and then use the results to predict the performance of a new untested athlete. The regression tool uses the worksheet function Linux, but again, we are not going to be using um, this. We are going to be using something else to solve for the regression function. Now, pay attention to the last line of this explanation. It says that those particular attributes of performance, such as age, height, and weight, you have to analyze them, because if you must get another athlete to be in your team, you need to find out what is the person's age, what is the person's height, and what is the person's weight. I don't know about the United Kingdom, but in the US, I think many times I've had people ask me questions like, "What is your height?" You know, in Nigeria, the only people where they ask me what is your height is tailor now. I tailor, they always ask me that question. Even when
Uh-huh.
I got my driver's license, I didn't know at the time what my height was. I thought I didn't bloody care. The guys just looked at me and say, okay, you must be 5 feet, blah blah blah, and that was it. There was no tool to measure my height at the time. Probably it's only my tailor that would know my exact height. And I only started taking it seriously when I the guy who was sewing my clothes at the time was actually in another state and I was in another state. So I asked him to make a certain design for me and he asked for my
Measurement.
measurement and I had to get someone to do it and then that was where I even knew how tall I was and the length of my arm and things like that. But a typical American will want to know because it's the culture of performance, right? They want to know how tall you are. When you go to platforms like Tinder or Bumblebee or all those dating apps, you see the difference between when a Nigerian introduces herself and when an American does. Nigerian would say, well, I don't know, it's funny. Nigerian would probably tell you that she's not here for games. Don't. I'm not here for hookup. I'm not here for games. Serious minds only, and that's it. Very few of them go ahead to tell you certain qualities about themselves. Those who do will do that bluntly without paying attention to the details. But a typical American would tell you, okay, I got a good job. I am 5 feet 4. I am this. I am that. I am that. So they give you the details you have. I am Caucasian. I'm African American. I am from Mexico. Those details really actually help you to predict if you are going to enjoy having this person in your space. Okay. So it's the same thing with predictive analysis. For you to successfully have your prediction correct on a certain list of variables, you must be able to have access to certain qualities of your data set. For instance, we have the qualities of the predicted monthly cost. The company have told us, you know what, for this product A, every month I want to be getting, I am predicting that I should be earning so amount. Okay. And you can actually use this formula to help some of your students who are trying to keep in touch with, stepping up their GPA in classes. You could have access to their terminal GPA and help them calculate, predict, you know what, if you continue doing this compared to your previous terminal GPA, you can predict to say this you are going to have a first class, you're going to have a distinction, you're going to have a pass, you're going to have this. But in the normal African setup, our prediction is that if a child does not greet you in the morning, that child is definitely going to turn out to be a useless child. Okay. So our traditional predictive analysis tool was basically meant on behaviorism. Like you definitely look at the child, see the child's responses to behaviors in the external world, and predict the possibility of the child turning out to be X or Y. But for serious analytical tools like this, you definitely need to have the numbers presented before you. You need the numbers in terms of values like cost or numbers or letters in terms or numbers in terms of duration. So let's go straight ahead and look at how we can solve for this straight up. I don't know if you understand from this little explanation what
Yes,
exactly you
yes.
can.
I think what I can deduce from it is when you say predictive analysis, you're talking about having some set out defined factors that we can,
Uh-huh.
when combined together, we can use to predict an outcome. Say, for instance, if there are some bank loaning applications that all they need to
Yeah.
ask you is they take your bank statement they tell you to present one of your old bank statements. I know a selling bank that does that in Nigeria. They tell you to present your previous bank statement to a tune of about 3 months or 6 months, depending on how much you want to take. Then they compare your income, your current income, and if you are gainfully employed in full time or part time, then how long you have equally stayed in your current address. These are the factors they compare together, and the system
Mm.
automatically generates how much you are qualified to get by the virtue of those factors. So I
Mm-hmm.
think it that it's a predictive analysis that is applicable in that case. Because no, in the real sense, there's no singular factor that determines. All these other factors work together to determine what you are entitled to in the bank. And with this case, if a branch manager sees your, okay, even before you input it into the system, if you show him your bank statement, he sees your address and your utility bill, he sees your employment letter or your pay slip or whatever it is, he can get what you can get from that bank based on these three factors.
Mm. Yes, yes, absolutely. Thanks for sharing that. And you actually were not lying when you say that you are a smart student. Yeah, because sometimes, we just present the little theoretical definitions or explanations, or we feel that people will get, and then they can. It's kind of difficult for them to think outside the box to see how they can really uh, apply this to.
Real life scenario.
All right, so let's go back to predictive analysis now.
Hello, are you there?
So for us to solve for the predictive analysis for these values, we simply again go to our data analysis toolpath, and then when you go over there, you are going to choose regression because that's what we are choosing. And now you see that there is a difference between regression and progression.
Listen.
For the sorry, between regression and correlation. For correlation, you simply have to highlight all the columns that you want to create some correlation with. But for the regression, you have to look at the one that you would consider to be the dependent variable and the independent variable. Remember what I was trying to explain, the differences between the dependent variable and the independent variable. The
Mm-hmm.
dependent variable is a variable that can do what that cannot stand on its own. It will depend on something. Okay? And if you look at these whole values, what do you think is a dependent variable there?
That cannot stand on its own. Uh, the cost.
The cost. Thank you. Because I mean you can't just put month and cost and that's it. Okay. So we have to now choose the cost to be the have to choose the cost to be the input y range, which is the dependent variable. And then we have to go to the x range, which is the independent variable. And the independent variable, this is a variable that can stand on its own. You don't need anything. It can just tell its own story. So looking at what you have before you, what do you think is the independent variable?
Independent variables. The mate, the A mate, B mate, and C mate.
Exactly. Perfect. Those ones can stand on their own. Okay. So we can have this as our independent variables. Of course, you need to check your labels, okay, and leave others, and then make sure that we choose our output range, and we want to choose. Remember what output range is?
No.
It simply means that you want it to appear on the same worksheet.
Okay. Okay.
Yeah. So I want to choose each four, and then after that, we want to look at clicking on OK. All right. So now that we are done looking at this, let me open all of this up. Going to see all the values there. I could as well highlight and control all shift HOI, and then all of this would
Right.
be on their lane, but this is maybe lazy.
What if we double click that corner, the right corner by A1? Will it not work?
This one, right?
We double click it, that corner. Yes. I think it should.
I've not tried that before. I think
I'm not so sure. I think I have done it before.
I'm pretty much used to from
But
using formulas for every bloody thing. So actually, now we have our regression analysis here. We have the regression statistics, we have the multiple R, all of these things. They are things you can read up and try to understand how. I wish we would have the time to explain what ANOVA means and all of that. Well, let's see. If you want to, you can talk about. Well, let's just continue. So there is a formula to solving for this prediction, and that formula is, let me type it here so that you can see it. We have y equals to constant plus b1 times x1 bracket close plus b2 times x2 bracket close plus dot 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 infinity, of course, b
yeah, yeah.
b and x, and same thing. So this is a formula for that. Golden leaf. Right. So at every point in time, you must remember this formula when trying to solve for predictive analysis. Now, the question we want to ask is, of course, the y there is like predictive analysis. Y equals to constant plus b1. You must remember that the constant you see there is the line intercept, and that
Is that
line intercept, the line intercept.
Okay.
If you look at your, you have intercepts, you have A made, you have B made, you have C made. You have coefficient, you have standard error, you have P stat, you have P value, lower, upper, lower, upper. All of these values have their distinct meaning. And to actually understand each of them theoretically, even though I'm going to be talking about one of them a little bit more than the others, just click on the question mark sign here, symbol, and then type coefficient, type intercept. For instance, let's just type intercept. Let's see what is going on. Intercept. Let's see the explanation this will have. Okay, it says intercept function. Description. It says it calculates the point at which a line will intersect the y-axis by using existing x values and y values. And let me clearly show you by use of description what intercept means when I want to show you a graph. Intercepts on a graph. Okay. So you have probably done physics and math, and I've forgotten how they used to call this type of workbook during secondary school those days. But you have probably drawn some of these things during your mathematics exams or
Mm-hmm.
physics
Graph.
exams, right?
Yes.
Good. So all of these lines, these are all called intercepts. Okay. When a line cuts, when there are meeting points between the x-axis and the y-axis, that is what is termed intercept. So for our predictive analysis, when we look at our, when we look at the intercept, if you want to count, if you want to solve a graph, for this, you are, if you want to get a graph on this whole thing, with intercept, coefficient, blah blah blah. If this was to be presented in a graph, unfortunately it's not. You will definitely see that the lines crossing A, B, and C have been intercepted at 54.1448780. That's what it means. So you can continue reading to understand how that works out. And that intercept is actually what we term as a constant in this formula. Then B1, this is actually B1, this is actually our all the models that we have. It could be A made model, B made model, C made, and so on and so forth. And if you have another model, that is where you put B2. Now, X1 is the coefficient of that B1. For instance, the coefficient of A made is what? 8.494. This is a negative number. The coefficient of B made, which is going to be like B2 or X2, okay? X2 is minus negative 0.000 blah blah blah. The coefficient of C is 0.0002554.
What's B1? Sorry, coming. What's B1? Constant is
B1, yeah, constant is the intercept. B1 are all the models that you are being told to predict. For instance, the predicted monthly cost, the models here is what? 800, 800. And let's say we want to change this. So let me put this in the table. and then I'm gonna have Control T. All right, that is what I just did. It's totally inconsequential. I just wanted to see if they could relate with something, but it seems it's quite different. So that is B1. B1 is each of the values you have been given for the model. It's like someone is asking you to predict the cost of running his company or her company, and then you would be like, okay, for me to actually predict the cost of running your company, can I have at least previous values of what it took to for this model, maybe Volvo, um, how much did you guys make in a month in 2012? Okay. For me to tell you what you are going to be making in 2017, I need to know what you made in 2016, or sorry, in 2000 or 2001 or 2002, for me to make such prediction, to know the monthly cost, you know, for to know the monthly benefits this company is going to be having over a period of time. Are you following me?
Following, I'm saying,
Yeah. So let us get right to it. So we want to start by saying equals to, but before we do that, I want you to look at the p-value, the p-value of A made, B made, and C made. What did you discover? All of this.
you got level of
What did
and
you, yeah. L, the column L. What did
yes,
you notice?
there's nothing. I don't know what you mean by what I know. I can't see what I can only see the figures are in decimals. I can't see any significant thing to point out there that I can. Oh, that what am I supposed to watch out for there? I don't know.
Yeah. Um, for me, you would watch out for the fact that A made has the highest number of p values, followed by C made and then B made. Now, here is the thing about p value. Now, p value is actually a short form of probability value, and it means probability value or p value. What does it mean? It means any value that is between 0 and 1.
Mm-hmm.
Any value that is between 0 and 1. So normally, if I had my statistics correctly, none of these values are supposed to be more than 1. It is any value you have between 0 and 1. You can have
0.9.
0, you can have 1, you can have minus 0, you can have, all of those values. And you must remember that in p-value, if you have 0.05, it means, and if the values are greater than 0.05, the result is not statistically significant. It's just what it is statistically. Any value that is greater than 0.05 is not statistically relevant. and that is where A made comes in. Because I think that value is greater than 0.05. If you want to round up that value to the nearest number, you are going to have 1.0. But for the other one, you are going to, for B made, if you want to round it up, you are going to have 0.3. And for C made, you are going to have 0.4. It is only A made that has a higher p-value of 1.0 if rounded up to the nearest decimal. Now, when a number is less than 0.05, the results are actually statistically relevant. And when you have a number that is greater than 0.01, or sorry, less than 0.01, the result is highly statistically relevant. In other words, the probability value, the higher the number, the less relevant that value or that column or whatever you are have creating a p-value for, the less relevant it is. But the lesser the number, the highly statistically relevant that number is or that value is. Are you confused about this?
Yeah, I'm just trying to. I'm looking at the.
So I want you to go and research on what is called null hypothesis
Okay.
and p-value. It will help you. There is a correlation between these two, null hypothesis and p-value. If one is small, which is a p-value, the smaller the p-value, the greater the evidence that the null hypothesis is wrong. You can let's search for null hypothesis here and see. Okay. All right, probably not here. So p-value. Also again not here. So you may have to check the internet for that to learn. Because you have to find out what these two definitions or these two concepts would be. So,
Okay.
but if you want to define what p-value is, it is simply any value between 0 and 1. That is one definition you can give to it. And again, another definition is that p-value is a statistical measurement used to validate a hypothesis against observed data. It is a statistical measurement tool used to validate a hypothesis against observed data. For instance, consider your p-value to be you have a balloon and you have it filled with air, and somebody comes up and tells you, you know what, this balloon can never break because the air inside is so tight, so heavy, quality air. There's nothing that can break this balloon. It's so tight that if you press it, no matter how hard you press it, no matter whatever you use, it's not going to break and it's not going to lose air. And then for you to prove that that person is wrong, you now carry the balloon and put inside hot water. You now carry the balloon and put it under your bed and then lay on it. Or you carry a pin and just romance the balloon small, just prickle it a bit, and then poof, it
Mm-hmm.
goes off. What you succeeded in doing is that you were able to use your bed, the hot water, and the pin to validate the hypothesis against the observed data. And what is the observed data? That there is air inside the balloon. And what was the hypothesis? The hypothesis was that it was impossible for anybody to make the air inside the balloon to get lost. So think of p-value in that regard, that you are simply using a statistical tool or measurement to validate hypothesis against observed data. And in this case, what is hypothesis? Hypothesis is that we have predicted a monthly cost for A models to be $120, for B models to be $800, and for C models to be $1,000. So we want to test these values, these hypotheses, against the observed data we have, and this is our observed data. We want to test it against this observed data. And when we've done testing that, the result of that test is what we call p-value.
Okay.
So they don't ever forget that the lower the p-value, the greater the statistical significance of the
Significant.
observed difference. So that is why whatever it is, always look out for a p-value that is lower at every point in time. That is why in my calculation here, I am not going to include the A made, I'm not going to include the A made model because its p-value is actually higher than 0.05. Are you following?
Yeah.
So let us solve for this. So we say equals to, and the first thing we have is our constant, which is this intercept. Put that I20, and you put your plus sign, your open brackets. In this case, you can do this or do this, but I want to use open bracket and then put your B1, which is what? 800, 800. And then what else? You multiply it by what? By the B coefficient. And what is the B coefficient?
Minus
This one,
0. I-22.
minus 0. Yes. And when you are done, you close the bracket and don't forget your plus sign. And then you open your bracket again. And remember to have your B2. And your B2 is what? 1000 times
I-22.
1000 times the B coefficient and
I
sorry, the C coefficient, which is 0.00 blah blah blah. Okay, and then you close your bracket and hit enter. So this is you are now predicted that given this amount predicted every month and looking at our coefficient and the intercept and a p-value, this is how much that this company is going to be making roughly from each of these products in a single month. So you can see if the cost of having this product for month one is $58, you have 56, 52, 51, and so on and so forth. At the end of the day, when you are done, if this is the cost, when you are done making all of this in month one, between month one to the 16th month, this is the prediction that we are giving to you. And every month you are going to be having this amount. So that is it for predictive analysis. I don't know if you understand, if you have
I
any
do.
question.
I understand actually.
All right.
just that I understand this very well.